Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to go on and cover section 5.2, but before we do, we have a couple of questions that came in. So this is from section 5.1, number 18. It says, use the power of a product rule for exponents to simplify the expression. And the expression is -1/4 t to the 5th u to the 9th power, the whole thing squared. Okay. Sorry about that. Apparently I was muted. So this is from section 5.1, problem number 18. And it says, use the power of the product rule for exponents to simplify the expression. So we've got -1/4 squared t to the 5th squared u to the 9th squared. But -1/4 squared would be -1 squared over 4 squared, and then t to the 5th squared u to the 9th squared. -1, the quantity squared, would be +1. 4 squared would be 16. And then we've got t to the 5th squared, which is t to the 10th, u to the 9th squared, which is u to the 18th. So we've got 1/16 t to the 10th, u to the 18th. Or you could also write it t to the 10th, u to the 18th, all over 16. So either one of those. Any questions on that? All right. Let's take a look at problem number 30. So this again is from section 5.1, number 30. It says a bowling ball fits tightly against all sides of a cardboard box that it is packaged in. Find expressions for the volume of the ball in the box. Leave pi in your answer. Assume A is 6. So let's take a look at this picture. So what it looks like is this. We've got a bowling ball inside of a box that has equal distance for all sides. All right. So first of all, we need formulas. Well, the volume of the box would be the length of the side times the length of the side times the length of the side, or the length of the side squared. But the volume of the bowling ball, for that, we would need to have looked it up some information in the reading. I'm going to skip finding it and just go to this. V equals 4/3 pi r cubed, where r is the radius of the bowling ball. It says we're to assume that A is 6, A being the length of each side, which would also be the diameter. So the diameter is 6, which means the radius is 3 inches. Actually, it's not 3 inches. It's the diameter is 6x. Hang on. Let's go back to our picture. Okay, so each side is AX inches, and A is to be 6. So this is 6x inches by 6x inches by 6x inches, okay? So the diameter is 6x inches. The radius would be half of that, so 3x inches. So the volume of the bowling ball is 4/3 pi times 3x cubed, which is 4/3 pi times 27x cubed. 27 over 3 is 9 over 1. 4 times 9 is 36. So we have 36 pi x cubed cubic inches. All right. Then the second part asks for the volume of the cardboard box. So that volume would be the length of the side cubed, where each side is 6x inches. So the volume would be 6x cubed. 6 times 6 is 36, times 6 is 216. X cubed is x cubed, and that would be cubic inches. So here are your two answers. Any further questions on that?
No, nothing. You answered my question, so thank you.
I know. Okay. So now let's go on to section 5.2. So on, let's see, what was it? Friday, we looked at some rules for exponents, and we're going to expand that and look at some new rules today that we didn't talk about on Friday. Okay. The summary of all these rules are on page 364 in the regular textbook. That's in section 5.2. I don't know if in the loose leaf copy that some of you got, if that's included or not, if it's on that page 364. But anyway, there's some new rules that we're going to be looking at, as well as going over the old rules. Suppose I had 7 to the third power over 7 to the third power. Well, that would be like 7 times 7 times 7 over 7 times 7 times 7, right? And I could reduce that down and say, well, 7 over 7 is 1 over 1, and 7 over 7 is 1 over 1, and 7 over 7 is 1 over 1. So I get 1 over 1, which is 1. So 7 cubed divided by 7 cubed is 1. Let's say we looked at 7 cubed over 7 cubed, and we multiplied it out, 7 cubed, and we got 343 over 343. Wouldn't that also just equal 1? Okay. What if we use the rule that we learned back in 5.1 that said, when you're dividing two powers with the same base, you take the top exponent minus the bottom exponent and attach it to the common base? When I do that, I get 7 to the 0 power. Well, if this equals 1 and this equals 1, then this must also equal 1, which leads us to the following rule. A base raised to the 0 power equals 1, as long as the base itself is not 0, okay? So anything other than 0 to the 0 power, so a is not equal to 0, okay? A variable raised to the 0 power equals 1. Now don't confuse that with a to the 1 power equals a, okay? When there's a 1 exponent, that's implied when you don't write any exponent. But when there's a 0 exponent, the whole thing is equal to the number 1. All right, now, another situation. Let's say we've got x to the 4th over x squared, okay? So that would be x to the what? 4 minus 2, or x squared, because we subtract the bottom exponent from the top exponent to get the result. Well, what if we had x squared over x to the 4th? In this case, we'd have x to the 2 minus 4 power, or x to the negative 2 power. Let's do this same problem, but let's do it the long way. X squared would be x times x. X to the 4th would be x times x times x times x. If I reduce this down, I get 1 over x squared. Well, if this equals that, but it also equals that, then it stands to reason that these should be equal. X to the negative 2 power equals 1 over x to the positive 2 power, which brings us to this rule. If we have a base raised to a negative exponent, that's equal to 1 over that base raised to a positive exponent. In other words, this is the reciprocal of, let's see here, in words, I forget that. Okay, anyway. All right, Let's see, and we've got some other variations on this rule. If we have 1 over x to the negative n, that's x to the positive n. So basically, we can, if it's up in the numerator with a negative exponent, we can move it downstairs and make it a positive exponent. If it's a base to a negative exponent in the denominator, we can move it upstairs to make it a positive exponent. We can also do something like this. Let's say we've got that. Let's write that a little more legibly. We can move this downstairs and that upstairs and get y to the positive n over x to the positive m. Okay. And finally, we've got this rule. Let's say we've got this, a fraction to a negative exponent. That's equal to the reciprocal raised to the positive exponent. Okay. So these new rules, we're dealing with negative exponents and 0 as an exponent. Not always, but most of the time, a final answer should be written without negative exponents. So if you had 7 to the negative 2 power, you would write it as 1 over 7 to the positive 2 power, which is 1 over 49. But you wouldn't leave it with a negative exponent. There are exceptions to that, but when those arise, they are talked about. Okay, so let's take a look at a bunch of examples. Let's see here. How about this? 7 to the 0 power. That would be equal to 1. 9 to the 0 power. That would be equal to 1. 1/4 to the 0 power is equal to 1. 3/8 to the 0 power is equal to 1. 2x to the 0 power, however, is not equal to 1 because the 0 exponent is not on the entire 2x. It's just on the x. So this would be 2 times, and then this would be 1. So that's 2. Now, what if we had this, 2x, the quantity to the 0 power? Well, that would be 1. Or if we wanted to find it the long way, that would be 2 to the 0 power, x to the 0 power, which is 1 times 1 or 1. But you've got to be careful. What's the base? Here, the base is just the x. Here, the base is 2x. So watch out for that. All right. What about this? 5 over 2x to the 0 power would be 5 in the numerator, and the denominator would have 2 times x to the 0 power is 1, so 5 over 2. Any questions there? Okay. It says express using positive exponents and simplify. 2 to the negative 2 power would be 1 over 2 to the positive 2 power, or 1 over 4. 7 to the negative 2 power would be 1 over 7 squared, or 1 over 49. 6 to the negative 1 power would be 1 over 6 to the 1 power, which is 1/6. Any questions there? All right. What about this? The quantity negative 5 raised to the negative 1 power. Well, that would be 1 over the quantity negative 5 to the positive 1 power, which would be 1 over negative 5, or negative 1/5, or negative 1 over 5. But recall, with a fraction, we don't leave the negative sign in the denominator. We either put it out in front or in the numerator in its final form. How about this situation? 2 to the negative 2 power plus 4 to the negative 1 power. Well, that would be 1 over 2 to the positive 2 power plus 1 over 4 to the 1 power, which would be 1 over 4 plus 1 over 4, which is 2 over 4, which is 1/2. How about this one? 9 to the 0 power minus 9 to the negative 1 power. 9 to the 0 power is 1, and 9 to the negative 1 power is 1 over 9 to the 1, which is 1/9, and this would be 9/9 minus 1/9, which is 8/9. And how did I get from here to here? I needed a common denominator of a 9, so I multiplied by 9 over 9. Okay. It says simplify, do not use negative exponents in the answer. 15g to the negative 6 power. The negative 6 exponent is only applied to the g. It's not applied to the 15. So this would be 15 times 1 over g to the 6th, which is 15 over g to the 6th power. 27m to the negative 3 power is 27 times 1 over m cubed is 27 divided by m cubed. Okay, now this one's a little tricky. Negative 4 to the negative 2 power. Here, the base to which the negative 2 is applied is not negative 4, it's just 4. If we had this situation, then the base would be negative 4, but we don't have that. So this is like negative 1 times 4 to the negative 2 power, which is negative 1 times 1 over 4 squared, which is negative 1 times 1 over 16, which is negative 1/16. So be careful. This situation would be 1 over negative 4 squared, which is 1 over 16. So be very careful with the subtraction or negative signs. Okay. Again, it says do not use negative exponents in the answer. Simplify. 1 over 5 to the negative 3 power would be 5 to the positive 3 power over 1, or just 5 to the positive 3 power, which is 5 times 5 times 5, or positive 125. 6 over k to the negative 2 power would be 6 times k to the positive 2 power, or 6k squared. And here again, the 2 is only attached to the k, not to the 6. All right. Here's a situation where we've got a negative exponent on top and a negative exponent on the bottom. So 2 to the negative 4 on top is 2 to the positive 4 on the bottom. 3 to the negative 1 on the bottom is 3 to the positive 1 on top. So I get 3 over, let's see, 2 to the 4th is 2 times 2 is 4 times 2 is 8 times 2 is 16. Okay. Any questions there? Nope. All right. Negative 9m to the negative 1 over n to the negative 30. Well, the negative 9 is not an exponent, so it stays put. The m to the negative 1 moves down below and becomes m to the positive 1. The n to the negative 30 down below moves above and becomes n to the positive 30. So we've got negative 9 n to the 30th over m. You could also write it like this, negative 9 into the 30th over m. So you could put the negative sign on the numerator or out in front of the entire fraction. Okay. Well, continuing on, simplify it says we've got 1/7 to the negative 2 power. So that would be 7 over 1 to the positive 2 power. But 7 over 1 is just 7. So we get 7 squared or 49. A over x to the negative 10th power is x over a to the positive 10th power, which is x to the 10th over a to the 10th. Here again, it says simplify. Do not use negative exponents in the answer. We have m to the 10th times m to the negative 6 power. Recall from section 5.1, multiplying two powers with the same base, you add the exponents and attach them to the common base. So this is m to the 10 plus negative 6 power, which is m to the 4th power. And let's see here. t to the 7th over t to the 10th is t to the 7 minus 10, which is t to the negative 3 power, which is 1 over t cubed. Y to the negative 3 power over y to the 4th is y to the negative 3 minus 4, which is y to the negative 7 power, or 1 over y to the 7th. Let's take a second look at this problem. A different way we could look at it is we could say, well, let's take the numerator and move it downstairs. So we get y to the 3rd times y to the 4th, which is y to the 7th. But keep in mind, there's still a 1 in the numerator. Let's see here. We have y to the negative 3 power squared, a power raised to a power. You would multiply the exponents. So this is y to the negative 6 power, which is 1 over y to the positive 6 power. If you have 11 r to the 10th, s to the negative 3 power, the whole thing squared. This is 11 squared times r to the 10th squared times s to the negative 3 squared, which is 121 r to the 20th, s to the negative 6, which is 121 r to the 20th over s to the positive 6th power. Okay. Again, any questions there? Are we doing all right, Karina? Okay, I'll take that as a
yeah. I'm doing fine. I was just writing it down as I go because that's what I kind of keep notes like that. So.
And if I'm going too fast, tell me to slow down.
Oh no, you're fine.
All righty. Let's see here. It says, again, simplify, do not use negative exponents in the answer. X to the negative 12 over x to the negative 3 times x to the negative 4. Because we don't want negative exponents in our answer, some people think that you automatically have to switch everything around to what it takes to make them positive exponents. You don't have to do it at the beginning. You can always do it at the end. It's kind of up to you. But let's see, this would be x to the negative 12 over x to the negative 7, right? Because in the denominator, you would add the exponents and attach them to the common x. We could even go further and say, well, this is x to the negative 12 minus negative 7, right? Top minus bottom, which is x to the negative 12 plus 7, which is x to the negative 5, which is 1 over x to the 5th. Okay, that's one way of getting it. Okay, here's another way of doing the same problem. We could move everything around and make this x to the 12th on the bottom, x cubed, x to the 4th on top, x to the 7th over x to the 12th, x to the 7 minus 12, x to the negative 5, 1 over x to the 5th. Again, as long as you're using the rules correctly, there may be more than one way to arrive at the final answer. Let's see here. 6 to the negative 2 power times b to the 9th times c cubed all over 5 to the negative 3 power b to the 4th times c to the 8th power. Well, I'm going to take the 6 to the negative 2 power and put it down below. So I'm going to get 1 over 6 to the positive 2 power. And then I'm going to take the 5 to the negative 3 down below and put that above and make it 5 to the positive 3 over 1. So what I've done is taken these two and switched places so that they have positive exponents. Okay. Now this is b to the 9 minus 4, which is b to the 5th on top. And then this would be c to the 3 minus 8, which is what? C to the negative 5. So now I've got, let's see, 5 cubed is 125, b to the 5th. On the denominator, I've got 36. Oh, let's move this downstairs and make that c to the 5th. Okay. So final answer, everything's multiplied out and has positive exponents. Okay. How are we doing for time? Still got lots of time for lots of examples. Simplify, do not use negative exponents. Assume that no variables are 0. N to the 8th power divided by 9m, all to the negative 2 power. So we could take the reciprocal to the positive 2 power. So then on top, we've got 9 squared m squared, and on the bottom, n to the 8th squared, which is 81 m squared over n to the 16th power. Okay, let's see here. M to the negative 30 over m to the negative 40 is m to the 40 over m to the 30 is m to the 10th power. Negative 9, the quantity to the negative 2 power, is 1 over negative 9, the quantity to the positive 2 power, which is 1 over 81. So in this case, the base is negative 9. It's not just a 9, but the negative 9 because it's enclosed in parentheses. How about this one? X, Y, Z over X squared Y all to the 0 power. Well, that would be equal to 1. Okay, 24 g to the 0 h squared would be 24 times 1 times h squared, which is just 24 h squared, because recall, something to the 0 power where the something isn't 1, or excuse me, isn't 0, is equal to 1. Okay. How about this? Y to the negative 2 times y to the negative 2. That's y to the negative 2 plus negative 2, which is y to the negative 4, which is 1 over y to the 4th. And how about this? 8 to the negative 1, negative 8 to the negative 1, negative 8 to the negative 1, and negative times negative 8 to the negative 1. So this is what? A, B, C, and D. So 8 to the negative 1 is 1 over 8 to the 1, which is just 1/8. Negative 8 to the negative 1, here the negative sign is not part of the base, so this is negative 1 over 8 to the positive 1, or negative 1/8. Part C, the negative 8 is part of the base, so this would be 1 over negative 8 to the 1, which is 1 over negative 8, which is negative 1/8. Okay. And then what have we got here? Let's see. Negative times negative 8 to the 1. Negative 1 rather. Well, that's negative times 1 over negative 8 to the 1, which is negative 1 over negative 8, which is 1/8. Okay, fun stuff there. All right, well, this is 5.2. So for tonight, you've got section 5.2 to do, and I'll go ahead and stop the recording.